If you take one step, then you will be a little closer to your dream than if you stay just where you are. Keep that chin held up and fight your battles with your feet, and both bear you'll find a path that has your name. Here I am, I'm ready to go again, ready to say goodbye when the sky is high. No reason to stay on ground. Lift your hands and you can touch and fly. The minute you felt you found, understand that you can have it all. The wings are in your soul. We're not letting go of the need to be an image that you've sketched on pages of your mind. Just watch it fade away. Give your powerful consent to be a traveler guided by your gift. You'll find that you're a guide yourself. And here I am, I'm ready to go again. I'm ready to say goodbye when the sky is high. No reason to stay on the ground. Lift your hands and you can touch and fly. The minute you felt you found, understand that you can have it all. The wings are in your soul. When the sky is high, no reason to stay around. Lift your hands and you can touch and fly. For glory is where you're bound. Understand that you can have it all. The wings are in your
Good afternoon, everyone. I see there are still 0 empty seats, so that's excellent. And we still have people coming in, so if you have any empty seats next to you, please raise your hand. There's 1 seat here and a second one here, so 2 first ones will get a seat. 1 sold and 1 still there. So 1 lucky one will get a seat. My name is Janne Pelio. I'm a project director at Citra's Climate Solutions team. So from day to day, I work with especially climate change and technologies and policies on tackling climate change. But today, I have the privilege of taking a different hat, and I will be moderating this carbon neutral industry session. Today, of course, everyone knows that we are faced with a massive challenge. If you look at the IPCC numbers on the global carbon budget that we have left and remaining in order to limit global warming to 1.5 degrees, we can roughly count that it's 10 years with today's emissions. So basically, within 10 years, if we continue on the path where we currently are, we have exhausted our carbon budget, allowing us to limit global warming to 1.5 degrees. And that's a very short time. So we need to cut down emissions dramatically, deeply, and as fast as possible. and we need to reverse the trend on increasing emissions with increasing economic output. And that brings us to the topic of today, as materials use is growing globally, and that's of course one of the key drivers in global economic growth, but at the same time, that's one of the key drivers in global growth in global emissions. Today, just a few key materials, steel, plastic, aluminium, and cement account for around 20% of global emissions. And if no changes occur in the production, use, and utilization of these materials, only the use of these materials will exhaust the 1.5 degree compliant carbon budget globally. That is quite a big challenge, but today we are here to talk about how to tackle the issue and how to make it in a way that's just and fair and profitable for also the businesses. And despite portraying quite a gloomy landscape in the beginning, I'm quite optimistic myself that the technological innovations that we already hear from or hear about at later stage of this session today, they inspire me, and I hope they inspire also you to see that there is a vast potential if we just align policies into the right direction, and if we encourage the technologies and the innovations to move into a cleaner and to a more circular world. The structure of the session goes as follows. First, we will be hearing a keynote presentation on how circular economy potentials can be utilized and captured in key raw material sectors. And then we hear a comment from policy side, this time from the European Commission. And after that, we will have three top-tier experts from industrial companies showcasing the best practice examples they've developed and are being developing. But without further ado, I would like to invite Mr. Per Klevnes on stage. He will help us to understand the big picture. What's the size of the challenge? What's the size of the prize? And how do we get there to capture that? So Per, the floor is yours, and here's the ticker.
Very good. Thank you for that introduction, Janne, and thank you all for coming here today. And I wanted to just start with a few framing words, because what I'm talking about now could be about to talk about for the next 25 minutes could be talked entirely in terms of CO2 and carbon and climate, and we could talk about 500 million tons of emissions in the European Union. We could talk about where they need to go. But we could also get from a completely different angle. We could talk about materials. We could talk about the fact that we will need steel for infrastructure. We will need aluminium for a number of value chains. We will need chemicals. We need cement. And surprisingly, these two worlds very rarely meet. And the study we're trying to do here is trying at the highest philosophical level, if you like, to answer the question, how can we continue to have the materials basis for our societies in an economy that emits no net CO2 emissions? And surprisingly, you'd have thought that this is something we have answered all ages ago. But unlike energy, where we can see a way forward through renewables and other low-carbon sources, or buildings with energy efficiency and transport with electrification, there's been much less attention on what are some very difficult emissions to address from the climate side. And when you go from session to session here at the World Circular Economy Forum, lurking in the background somewhere is the production of materials. And that once we have produced a kilogram of steel or cement or plastics, how can we get as much economic value as possible out of them? And so we try to marry these two perspectives in the study. It's quite climate heavy, but it relates very directly to all of what the rest of the World Circular Economy Forum is about, which is to find a better basis, material basis for our economy in decades to come. I wanted to start by telling you what I am going to tell you, and it's roughly as follows. It is possible to continue, it's good news, right? To continue having all the materials we need to underpin mobility and infrastructure and packaging and all the rest by 2050, and to do so in a climate-neutral way in Europe. And what makes this possible, and what makes this positive message possible, is that the solution set here is much larger than is commonly understood. And because we're at the World Circular Economy Forum, I want to particularly stress that there's a tremendous opportunity to use these materials better, to get more economic value out of each ton or each unit of material that we produce, and that can be combined with clean production, with like carbon capture and storage for a total net zero solution. but that half the solution or more, if you want to remember one world, is on the demand side, is in a more circular economy. However, if we're going to get there, we must talk about cost. Not because this is going to be tremendously expensive for society as a whole. As a consumer, when you buy a car, you buy a house, you buy packaged goods, maybe you'll pay just 1% more. But if you're a company producing steel or producing clear cement, you will face costs that are much higher than a high-carbon competitor. And that must be handled if we're going to move forward with this agenda. And by the way, much of what I talk about here will be true also of pulp and paper, or ceramics, or glass, or many other heavy industries. The third message I really want to get across is how short time is here. 2050 used to be a long way away when I started working on these topics 15 years ago, and now it's one investment cycle away, or if you like, getting a much more circular value chain in place in the time period we're talking about. New business models up and running, reorganizing mobility in that time span is a huge challenge, and we need to start yesterday if we're going to succeed. The fourth message really is that if we go for this agenda, we would go from one where we use tremendous amounts of coal, of oil and gas to propel these industries and get the benefits from all of these materials used, to one much more geared towards electricity, towards use of biomass, and towards resource efficiency as the new sources of inputs to this economy. So in addition to investment and capital, we need an entirely different supply system surrounding these industries. And then finally, very little of this will happen at the speed that we require unless policy starts to move in a different direction, something we'll talk more about later in the session, of course. But let me dig into some of the details. There will be lots of charts, lots of data, and this is deliberate, because this is a space where there's a lot of opinion, there's a lot of uncertainty, but if we're going to have policy, and if as a business you're going to make the right investment decisions, you need a basis in data and in quantitative information to understand what choices that lie ahead. So let me start. This, I would say, is a very sterile representation of what we could call the EU material system. We typically just talk about the production of materials, and we use 400 million tons of just these three, steel, chemical, cement, per year. Now, that's 800 kilograms for every one of you per year, and you can work out what that means per month. You're getting through your body weight of these materials quite fast. So this is a big deal. You don't see it, but this is a big deal. And in society, for each and every one of you, there's 12 tons of cement. Each and every one of you uses 100 kilograms of plastic every year. And that is produced. It is produced out of view. We don't know so much about it. But it's also used. And this is a key part. If we're going to talk about fitting these materials into a carbon-neutral economy, we need to talk about where they are used. They are used in construction, infrastructure, transportation, in packaged goods. And that's where a lot of the change needs to happen. So in addition to production and use, you have the final one, which is the end of life. Materials don't go away. Their use stops, but we recycle steel, we recycle aluminum. We do recycle plastics, not as much as you think we do. But that's a huge potential in using these end-of-life materials as raw materials for new production. So we looked across all of these, and then we did one more thing. We looked at the emissions from this. And this is a hideously complex picture, and you guys at the back will have a challenge here. But what it's trying to say is that of those 400 million tons we have, they emit cement least per ton, but you use a lot of it, but up to 3 kilograms for every kilogram of material produced for plastics. And a lot of these come from process chemistry. They come from very high temperatures. They come from what happens at end of life. These emissions are very hard to cut. The gray ones at the top is what we can address with traditional climate measures, low carbon electricity or increased energy efficiency. And the other ones, we have to make fundamental changes to the production or to the separation of CO2 or how we use the materials. And this is why we sometimes call these hard to abate. That's the scope of our study. We looked all the way upstream to electricity, all the way through to end of life in order to try and find a solution here. The bleak picture, in a way, is that this emits 500 million tons of CO2 in the EU. And now, this is not as much as electricity, but as other sectors go down, unless we change this picture, we are going to find ourselves in 2050 with just about the same amount of emissions here, because we are near exhausting the low-hanging fruit. We need a transformation if these sectors are really going to cut their emissions in a meaningful way. And in some sectors, it will even increase. As we burn more plastics in particular, even more emissions will result on a whole life cycle basis from that particular material. So much for the problem. What can we do about this? And I would like to divide it into 4 discrete strategies that we look deep into. And we didn't do this with a CCS agenda or a circular economy agenda. We try to look at everything, right? And nonetheless, we found that the circular economy is an absolutely key part of the answer. So the first strategy we call materials efficiency in new business models. This is for every product you make, every car you make, how much service can you get out of it? For every car you make, how much material do you really need to use in waste in manufacturing, in lightweighting, and then in new business models such as sharing. And we found that the abatement potential here is something like 1/3 of the total emissions through these types of levers, depending on how optimistic you are about how much we will go towards a more circular economy with more reuse, etc. The second category is materials recirculation and substitution. The higher rates of recycling of steel and plastics, and also chemical recycling of plastics are big levers here. And again, almost 200 million tons of abatement potential here in emissions that we can cut by doing what we anyway ought to be doing, reusing a resource again once we've produced it. So together, these could be half or more, as I said, of the total solution. And they're starting to seep into the discussions, but even a few years ago, they were not part of studies that tried to look at the climate problem. And if I want to take one message from our study is that we urgently need to merge the climate and the circular economy and industrial agendas if we're going to succeed in this space. But we will also need to make new materials. We can't just live off what we already have. And certainly globally, there's a huge need for new steel, for new plastics, for new cement. So we need clean production methods. And so we looked a lot at new processes that shift away from the fundamental innovation in how these materials are produced. And that's another big piece of the puzzle. And then we looked at carbon capture and storage, which could be large or could be small. We need it, not least in cement, but it may not nearly be as large as has often been assumed. And what we did was we estimated each and every one of these. So we looked at all of those uses in value chains and all of these materials, and we added all of them up. So behind this picture, you will see something like 40 or 50 measures, ranging from greater reuse of building segments to a less overspecification of steel in building frames, to remanufacturing opportunities, to reconstruction of rather than demolition of buildings, to radically new business models for shared mobility, all with the same theme that we get more economic value out of what we do. And the same picture for materials recirculation and substitution, where we found in particular for plastics, you see the lighter of the blue there shrinking substantially with a much higher recycling rate, not just via mechanical recycling that we do today, but via chemical recycling where you use plastics as feedstock for new production. All of this needs to be done with clean energy, with lots of electricity inputs, and with tightly controlled processes, but it is fundamentally almost always a big reduction in CO2 emissions whenever you reuse a material again. And cumulatively, it's a big opportunity. We looked far and wide at loads and loads of different new potential industrial processes. Producing steel using hydrogen, or an entirely new metallurgy that involves carbon capture and use, electrification of heating across all of these sectors, including high-temperature heating. We looked at entirely new chemical platforms such as methanol, and we looked at new binders in cement, and when a lot of these have been in the works for a long time, but have not been developed to scale. And why? Because they do not compete with a high-carbon process that does not pay its full price. And because of that, there's a huge need to accelerate innovation if the clean production side of this equation is also going to come. But the good news, again, is there's a wide menu to choose from here and to further develop, and we're starting to see some extremely promising commercialization of these already today. And finally, we looked at CCS. And the gray here is a sort of minimal use of CCS that we think is necessary, maybe 50 million tons. It's still a big volume, and it's mostly in the cement sector that this would be needed. But there are opportunities to use carbon capture and storage across steel chemicals, across waste incineration, across hydrogen production, if that turns out to be the way society wants to go. And this, I think, is an important turn of phrase here, right? So we have all of these menus of solution. Which one should we do? And let me just not try to answer and say it's definitely one way rather than the other, but to point out some of the implications in terms of cost and investment, resource use. What we did was we put together 3 pathways. One emphasizes these new processes significantly. The other one a more circular economy, and the final one emphasizes carbon capture. All of them, I should emphasize, use all of the solutions. There's no such thing as saying we can do without X. We need everything if this is going to happen by 2050. But in all of these, the circular economy, which are the two top ones, even if you're really pessimistic about it, is an indispensable part of the picture. And it could be as much as I said, 60% of the solution, or even more in one pathway where we make this really the focus of our efforts. And as you'll have heard all over this conference, there are so many other benefits to this. From reduced externalities in mobility systems to reduced water use to all sorts of other benefits. And so we shouldn't just look at this from a climate agenda, but from a much more comprehensive one as well. But you could also ask yourself, is one of these much costlier than the other? And how much will it cost if we want to do this? And so we model that through. And overall, in 2050, on these materials that we cover, so in addition to plastics, we cover some other basic chemicals such as ammonia, and we cover cement, and we cover steel. We would spend something like 200 billion a year. Now, is this a lot? Compared to the EU economy, maybe, maybe not, right? And we talk about an increase of maybe 40 to 50 billion euros per year. This is not a large amount of money compared to GDP, however you want to calculate this. Moreover, what we found is that it's very uncertain for the circular economy. Will we be able, with a more circular economy, to also capture some of the immense productivity improvements inherent in reusing materials rather than reusing new resources, in the productivity in using much more shared mobility and other models, etc. And if we can capture those, we found that the costs could be barely higher than the baselines. We could cut emissions to zero and barely have a higher cost of the total system than we do today. If you're less optimistic, it's still only a cost increase of something like 40 to 50 billion euros. And as I said initially, that translates into costs on some of the most important materials using categories that are barely noticeable on an annual fluctuating basis. However, if you're a company in these sectors, you see this from an entirely different end of the pipe. You see that you need to use a steel process that costs 20% more than your competitors at the same time as you're being outcompeted at 10 euros difference today, right? Or you see that in chemicals, you might have to use something that costs 50% more than the current very efficient process of cracking oil into its constituent parts and building it into plastics or making hydrogen from gas for ammonia. And for cement, likewise, the cost difference is very marked. This is a real competitiveness problem. It's a problem to get people going, because why would you invest if there's no business case in the future? It's a problem of international competition and carbon leakage, and it's a problem of innovation because we have so little time that we need these things to happen as soon as it's humanly possible. So one needs to keep two things in mind here. One is that the cost is entirely manageable for us as an economy and society, and nonetheless, it is very difficult for an individual company to take the first step. And that's the job of policy. And it's a job of collaboration along value chains to solve this problem and do it urgently. Another major message is that we will need a lot of investment. Now, the line here is how much we might ordinarily invest in these industries to keep current capital assets going, and in order to replace the current system as it gradually ages. And we say, if you want to build an entirely new low-carbon system, investment is going to have to increase a lot. It will need to double, or it will need to, in the 2030s, be substantially higher than that. For a company wanting to invest, choosing not to invest in its current assets, this is a big decision. It's a bet the company decision, because what you have as a basic materials company is your production assets and whatever you might be slightly better at running those than others are. And so if you choose not to invest in that, you really are betting your company. And you will need a lot of comfort that there will be demand for your now more expensive production method in the future, right? And so although these investment amounts, measured in a few single-digit billion euro numbers, are very small compared to investment, mobilizing investment in these sectors, which moreover are not earning their cost of capital today, would be very difficult. And by the way, these investments are also in circular economy solutions, in entirely new businesses, in new logistics systems, etc. We try to estimate them as best we could, but you will find also that the circular economy numbers here are lower than they are for in total here than they are for some of the others, because these are less capital-intensive solutions overall. Finally, a word I promised I'd talk about inputs, and here I think is complex way of conveying exactly how powerful a more circular economy can be. Today we use something like 8 exajoules. Now an exajoule, think of it as something enormous. It's just a lot. 8 exajoules of natural gas, coal and oil, and a little bit of the red, the electricity. That's roughly what these sectors use today. And we pay a lot of money for this, and we import a lot of it into Europe. And it would be a radically different structure of inputs if we go for a net zero solution. And in particular, pay attention to the middle column here. And the circular economy hits it from 2 directions. One is that with lower new virgin materials production, something like 3 out of these 8, or would be increased to 9 or so as production increases, can be done away with by reusing materials again and by using them better. Instead of using new energy as well as materials, we can do away with a lot of that. And the other is that at the bottom here, we have done the absurd thing of expressing end-of-life plastics in energy terms to illustrate that it can be a feedstock into the system. So once you take away the gray, that's what you have left. The resource efficiency of a more circular economy could not be more prominently on display. Nonetheless, you need tremendous amounts of electricity and the lighter red bioresources if you're going to be able to do this. And bioresources mostly as a feedstock to build new chemicals, but also to some extent for energy. And mobilizing this electricity is no small matter. We could carry on using fossil fuels with carbon capture, but in no way can we carry on using as much fossil fuels as we do today and hope to capture all of that CO2. It's still a very small minority. I wanted to double-click on the electricity. And now we're suddenly with terawatt hours instead of exajoules. A terawatt hour is also a very big beast. Think of the total electricity system in the EU being around 3,000 terawatt hours. And I'm putting up numbers here saying that these sectors alone need maybe 1,000. And it's not a surprise. We need to electrify cars. We need to electrify building and heat. And we know that we can get electricity cheaper than we could ever dreamed of 5 or even 10 years ago. But nonetheless, here's a huge new claim on our electricity resources from industries that have not used them before. And how we then therefore rejig our electricity system, how we enable long-term contracts, how this is procured by businesses is going to be very important. And perhaps there's an affinity here to a circular economy that's not obvious. The circular economy was one of electricity-driven logistics, one of electricity-driven data, that also will need inputs that are essentially electricity if we're going to propel it in the future. All of that is all very well and very technical, but how do we get it to happen? To some extent, it is already happening. I talk to companies every day who are waiting in the wings, who have a good idea, who are trying to do things, and who are on the cusp of doing something more than they did before. Nonetheless, these are transformative changes. They're either transformative in how these value chains are organized and use their resources, or they're transformative for industrial companies that need to fundamentally reinvent their resources, or they're transformative for the infrastructure, for hydrogen, for electricity, for carbon capture that we need. There's a very big agenda here. And all of this has to be done while keeping production in Europe. If the solution is we export our industry instead, then we have achieved very little, because there is no other region that is going to lead with the solutions we have sketched here if Europe does not. So we identified 6 areas of policy that we think must come together. Clearly, there's a carbon price somewhere in the background here. We have the EU ETS, we have a carbon price. Clearly, in our view, that is also not going to be enough to really drive this full agenda. So number 1 is that innovation is needed here. And we need an innovation spree in circular economy solution, in experimentation, and in the development of new processes that accelerates at a pace double or three times what we've done to date. Or we're not going to be able to scale up these solutions by the 2030s when we really, really need them. So we need large demonstration projects, we need lots and lots more collaboration, we need to make this a pillar of EU innovation policy and of national innovation policy. And we need, as a second one, we need lead markets to support the business case here. It may not be enough that we have a gradual increase in carbon price. We may need to do what we did in electricity and create the first ring-fenced market where pioneers can act and know that they are not going to be investing into the void. And that is then the policy solution for that. I don't want to get into, but the policy commitment is going to be absolutely essential. Maybe we also need to actually explicitly address the investment. Not because the amounts are enormous, but because the first investments are incredibly risky for anybody who's trying to transform their business. And so here's a really good case where public support can make an enormous difference to start the journey. And then we need 2 circular economy pillars of this edifice. High quality recirculation, we could say, but we have recycling targets. But no, we are recycling 5 million tons of effective plastic replacement in Europe. We are exporting plastics, we are not recycling it. We are downgrading plastics, we are not recycling it. And while I don't want to do down what we've done to date, it's nowhere near enough the recycling rates we're talking about here. We need to address the contamination of steel by copper, which downgrades it so it can't be used to the same extent again. We need to solve the problem of aluminium recycling, which is also downgraded and can't be used in all the ways it is. We have a lot of work to do on materials recirculation. We need to capture the materials efficiency potential. And here I would suggest that this is an agenda very similar to energy efficiency, of addressing a host of small barriers along value chains where we can't hope that price signals get through, where there are lots of market failures, where there's a lot of need for a lot of coordination and for leadership role for policy. And finally, there's an infrastructure challenge here, where the electricity networks, where in particular, and the electricity production needs to be available if industry is going to be able to move. So here's a lot to get on with. No small ask. But our report is very much a message to policymakers to catch up with business. Because I think in this agenda, to a very large extent, business are actually ahead. They're waiting in the wings to develop some extremely exciting solutions. And we now need a policy framework that makes it possible. I told you I was going to say that. And here we are. Thanks very much.
Thank you very much, Per. At the same time, it's quite a shocking presentation. I've seen the materials, I've read the report, but every time when I see the numbers and the figures, I'm quite shocked by the magnitudes and by the size of the challenge. But at the same time, it's a limited amount of measures that need to be undertaken ambitiously, strategically, and in a structured manner. And that's how we can get into that direction. So thank you very much, Per. And 12 tons of cement for each of you. That's quite a figure if you pile it up. But at the end of his presentation, Per touched upon the policy dimensions. And of course, that's an important part of the discussion. It's not only about the numbers that highlight the potential and the size of the challenge, but also how do we get there. And that's why we are lucky to have in the room a person who is an economist by training, and has been an official in the European Commission since 1985, and has been a director of the DG Growth since December 2008. His main responsibilities today cover the circular economy, energy union, and energy-intensive industries. And what are the odds that he's today here when we just talk about these items? So please welcome to the stage Mr. Kvenol Kojigu, who's the director of the DG Growth. Thank you.
Thank you, Janne. Thank you, Janne. Actually, I made it on the stage despite the number of kilos of cement I represent, which is already good news. It's quite difficult for me to take the floor after Per, because Per's presentation not only was complete, not only was excellent, but on top of that, we agree with most of his messages in the Commission. So I mean, I've got nothing else to add, probably. Perhaps a few things, and Per will recognize some of his messages already, that I would like to highlight. We are used to pressure on fossil fuels today. That pressure on fossil fuels is going to be replaced with the pressure on raw materials. I'm in charge also of the automotive industry. You might have heard about this European initiative to develop batteries value chain. And from the very beginning, we approached this as a value chain challenge. And of course, if you take the value chain challenge, raw materials are key. And that's a specific issue where circular economy is not automatically going to help, because we hope it's going to be an exponentially growing market, where basically if you remain in the same value chain, you're never going to have the quantities necessary. if you want to use, for example, the cobalt in mobile phones, you have to have mobile phones that can be dismantled and cobalt that can be recovered. That's that type of issues that you see, show you the interconnection. But just keep in mind, fossil fuels pressure will be replaced the more we go to our targets, Paris Agreement targets, with raw materials pressure. By the way, people speak a lot about lithium and cobalt. I would like you to draw your attention on nickel and copper. That's not widely used, but I mean, Per was mentioning infrastructure needs and investments. That will require quite a lot of copper to make all the grid function. And that raw materials pressure is one more justification for actually going for materials efficiency. The more you go towards circular economy, the more you diminish the pressure on primary raw materials. If only, I mean, if you don't want to be clean, if you don't want anything of environment issue, if you just want to be security of supply, just think of that. The more you use secondary raw materials, the less the pressure is high on primary raw materials. And that's what we are committed to do as far as the European Commission is concerned. Already a few years now, we adopted the first Circular Economy Action Plan. There was more than 50 measures, plus a revision of the Waste Framework Directive. The Waste Framework Directive revision has been adopted with the 50-plus measures. I think 52, if I remember correctly, have been fulfilled or well ongoing. We are definitely, I mean, of course, we want to have the circular economy we want, which is basically not a circular economy which is going to kill all our economy. We want circular economy that allows us to get the competitive advantage we're convinced that we can gain on the global market and on the European market, because products will be cleaner, they will be better, and their production process will be better. One aspect which is not, in my view, sufficiently mentioned, we want it also to be socially inclusive. I'm a French citizen. Some of you might have heard of people wearing yellow vests. That's not the proper way of going towards a clean planet. So we have to introduce the social dimension from the very beginning when we want to go for our climate objectives. And circular economy will be essential for it. Per mentioned it. I think one of your studies together with Citra shows that it could make up to 56% of the solution. So, I mean, imagine, more than half of the solution could be circular economy as far as our climate targets are concerned. It's not to tell you a secret, but you know, officials and politicians have to be elected. Officials don't have to. That's our privilege. But we have to obey once they're elected, so that's we pay back. But we are already reflecting together with our DG Environment colleagues, because circular economy in the Commission, and I'll come back to that, is co-led initiative between DG Grow, where I come from, and DG Environment since the very beginning, and we're already reflecting on the second circular economy action plan, which of course is subject to the endorsement of our next political masters, whom we don't know yet, but we expect them not to go 180-degree curves, so we prepare the future. I come back to the fact that circular economy policy in the Commission has been from the very beginning co-led between DG Grow, which is minding industry, the internal market, and DG Environment. And that's probably one of the reasons of its success, because from the very beginning, it was not either the environment dimension or the economic dimension. It was both, and not the one antidote on the other, but integrated into each other. And that makes the logic, that's the reason why basically it was well received. The Commission adopted an energy and climate vision 2050 last autumn with various scenarios. How do we get to our Paris targets, Paris Agreement targets? Circular economy is actually quite prominent in the scenarios. We are working on industrial policy, which the European Council has asked us actually to produce by the end of this year, and without, again, revealing secrets, Of course, carbon neutrality will be part of it, and when you speak about carbon neutrality, circular economy will be also essential. Let's talk about carbon neutrality because a lot of people talk about decarbonization, but think of us without carbon. We wouldn't go much far away. I mean, a society without carbon is a dead society. So it's not the idea of decarbonizing a society, is having carbon neutrality of our manufacturing processes. And perhaps a word, since I see that I've got a bit more than 3 minutes left, a word of what we are very concretely doing with energy-intensive industries at the moment. 2018, the Commission called on European industries, European energy-intensive industries, to come and reflect on how we could get to 2050 respecting our climate targets, but at the same time, we don't want to get there and have lost all our energy-intensive industries on a path towards it. So we want to get there with competitive energy-intensive industries, with thrilling energy-intensive industries, and that's a big challenge. As Per was saying, globally, if you look macroeconomic, if you look macroeconomic, it's not a problem, 0.5–1% price increase. But if you look at the energy-intensive industries and you look at the challenge they have to face, then it looks a bit differently. And I used to say that when you look at the Earth from the Moon, it's blue. The only thing is that if you look at the Earth from where we are, it's not everything is blue. There's a bit of green, there's a bit of buildings, there's a bit of everything. So that's basically the situation we are. Macroeconomically, no problem. Energy intense, but if you go a bit further in detail, then we have huge challenges to meet. And I'm very glad to say that on that call on energy-intensive industries, 11 European energy-intensive industries federations, cement, steel, chemicals, aluminium, ceramics, glass, paper, work together and actually came out with a roadmap, how they could, an integrated roadmap, first time, because some of them, or most of them, had produced their own way of getting there, but it was useful, but it was not sufficient, because exactly, we need a value chain approach, and we need a cross-value chain approach if we want it to function. So they've worked together, and we were worked to them towards a roadmap that was actually very instrumental. And if you look at what I was mentioning earlier on the Climate and Energy Vision 2050 of the Commission that was issued last autumn, there's an industrial chapter which is very much inspired by that contribution by industries. And now we're working together with the same industries, all Commission services potentially involved, and member states, in order to develop a master plan by the autumn so that we can basically have a better idea of what is needed, where, by whom, and when. So it's a huge challenge. We might not go to each detail by the autumn, but it's a process. And just to give you a hint of what we're doing, we've got 3 working groups there. We've got one which is dedicated to the creation of markets for climate-neutral circular economy products, because the difference of what we've been doing in the past, focusing on supply, it's very much something that has to focus on supply, but also demand. So we're going to look at how we can develop the markets, where are possible environmental benefits. Of course, it involves long-term carbon pricing issues. It involves also the coherent enabling policies, and I'll come back to that just at the end. Second working group is about developing climate-neutral solutions and financing their uptake. So it's basically about innovation, about how do you get the technologies needed in production. It's also maybe about taxation, fiscal incentives. And the third working group is about resources and deployment. So basically, how can you get access to key energy and non-energy inputs, like low-carbon electricity, gas, biomass, hydrogen, carbon capture. And perhaps there I would like to underline, CCS, I'm in charge of raw materials policy. Each time you want to dig a hole in Europe, you have a demonstration. Each time you want to do CCS, you've got half of a demonstration. If it goes on like that, we're not going to meet our climate targets. So people better start thinking, and actually, you can't have it both ways, guys. If you want it to work, CCS will be part of the solution, because from what Per and colleagues have been analyzing, circular economy is probably the main source of the main solution, but the second one is CCS. So it's a choice. Infrastructure, we were mentioning the grid, need to get the electricity where it needs to be there. Regional aspects, because there are carbon-intensive regions in Europe for which solutions will have to be found. And of course, circular economy. I did not mention social dimension, but it will be taken into account because it's a transversal one. Not only skills, but what I was mentioning in terms of low-income households and how to get there. When you've got energy-efficient buildings, for example, will the rents be more expensive? How do you make sure that the people who have low income can afford them, who can't do the upfront investment in order to gain the benefits of a cheaper energy afterwards? So that's another challenge which we have to keep in mind. Might not be at the European level, but might be at the national level. And that's perhaps what brings me to a conclusion. The Commission is not going to do it on its own. Commission and industry at European level are not going to do it on their own. Of course, we need policy coherence at European level. Regional policy, because there's a lot of money in terms of structural funds, but also energy policy, environment policy, climate policy, industrial policy. I did not mention trade and competition policy, but we might have to get there one day. But we also need coherence between European level, national level, and regional level, because a lot of this needs to be done in cohesion. And that's why actually in these groups we've got all the levels together. The challenge is incredibly high. We are convinced that we can do it, but it's not going to be that easy. It's a bit of a bumpy road, but there's no choice. We have to get there. And look, there's not only a challenge, there are opportunities, because there are markets for those products. At the end of the day, if the market signals are correct, then we can make it. So, thank you very much.
Thank you very much, Mr. Kosiku. It was great to hear that this is in the top of the agenda of the European Union. And of course, you're exactly right by framing it that it's going to be bumpy, but we will need to embark on the ride. And the sooner we start the ride, the less bumpy it's going to be. And that's why getting into the competitive advantage for Europe and European businesses in a socially inclusive way will be one of the key priorities going forward, both in the national level and in the European Union level. And that's why we need to talk about the competitive businesses that can really provide the innovations that are needed in order to take us to the pathway. And I'm lucky to be able to represent to you Mr. Martin Pei, who is an Executive Vice President and Chief Technology Officer at SSAB. I've heard about the project that you are having, and I'm quite excited. It's groundbreaking, I would say. Let's give a warm applause to Martin and have his presentation.
Thank you very much. I'm very happy to be here to talk about an initiative that we have been working with in Sweden and Finland since 2016. As Per already talked about, the steel industry is one of the what is called hard-to-abate sectors. Steel industry is representing one of the major carbon dioxide emitting industries in the world. And here in Sweden, we have a situation where we actually are emitting 10% of the country's CO2 emission annually. In Finland, the emission from steel industry is corresponding to the same number as global number, 7%. The steel industry has been using a technology to produce steel from iron ore since a very long time back. The technology, if you look at the chart to the left, the blast furnace-based route has been there for almost 800 years. In Sweden, we have found one very small blast furnace which has been there working for about 1,000 years. So this is a very established process, and steel industry is also, in terms of circular economy, the industry that utilizes recycled steel scrap extensively in our industry. But the world's consumption of steel can't be only supplied by recycled scrap. We need to make steel from virgin iron ore. And that is a situation where we need to find a technical solution to solve the emission issue from the industry. A lot of efforts have been done with CCS and CCU, now more on the topic, which is, of course, very good. But here in Sweden and also in Finland, we have a very interesting situation where we have the possibility to develop this new technology that I'm going to shortly introduce, the hybrid initiative. What we wanted to do here is that instead of using coal, which is taking away oxygen in the iron ore, we want to try to use hydrogen. With hydrogen replacing coal, we will get rid of the root cause of CO2 emission from steel production. And this chemically is known since a long time back. It can be easily done in laboratory, which we are doing today, but it has never been successfully scaled up to industrial scale. We started this initiative in 2016. 3 companies, SSAB, which is the world leader in high-strength steel, half of our production here in Finland, and almost another half in Sweden. We have also 2 steel mills in the US, which uses electric arc furnace route. We don't use blast furnace there. So that's the completely recycled steel scrap we use in US. But here in Finland and Sweden, we use the blast furnace process that we want now to challenge. So the steel value chain here in northern part of Europe, with SSAB initiating the initiative, we got very good support from LKAB, which is today the only major iron ore company in the European Union, and then the energy company Vattenfall. So we are creating this initiative. We have made a pre-feasibility study, which showed that this is technically possible, but we need to develop technology so that it can be scaled up. We got support from the Swedish government. We started construction of a pilot plant for 1 year ago, and this pilot plant is dimensioned for test purposes for making 1 ton of steel an hour. If you look at the blast furnace on the photo in the middle of the slide, it's our blast furnace in Luleå. It produces 300 tons per hour, so that you get the reference. So we want to test this technology at 1 ton per hour scale, and then when this is done, we will scale it up to a much larger facility in about 5 years. Our plan is to finish this construction next summer and start the testing of this technology for a few years. And we have already started transformation of one of our blast furnace production sites in Oxelösund, south of Stockholm, and that facility will be converted in 2025. So our plan is to develop this technology so that we can start to utilize it from 2025. Sweden has been the country with the most aggressive environmental targets until yesterday. So now we have to run faster. But this is a very exciting time, and we hope that we will be successful. And one good thing is that if this technology is shown possible here in the Nordic countries, it can be utilized in many other places where there is good access to fossil-free electricity. So really, I hope that, as Mr. Kosigo said, that there will be a market for these type of products. If that will be true, then this can really go fast. So hopefully that we find the solution to solve one of the most difficult problems of CO2 emission from one of the most important industries we have. Thank you.
Thank you very much, Mr. Pei. That is indeed a challenge. When we look at the process emissions, that's one of the hardest to abate. sectors, and that's why it's quite impressive that you have so much invested on the process of developing something new. Touching on the point that you made, not only to the point that Finland has beaten Sweden, that's of course important in terms of climate targets and in ice hockey as well, but on the other point that when we can show that we can make these technologies work here in scale in the north, then we can scale them up to other parts of the world as well, if there's plenty of clean and emission-free energy and electricity. So that is indeed an important point. But at this stage, I would like to invite the next speaker, who's the Director of Chemicals Management Policy and Circular Economy, and responsible for leading its Dow Chemicals Corporate 2025 Sustainability Goal, Advancing a Circular Economy. Please welcome with me Ms. Lorraine Francoeur.
Yeah, thank you. And I don't have a slide, so you're going to have to look at that dodgy picture of me for the whole 5 minutes. I apologize for that in advance. So we're in a really interesting situation, and I am part of a major chemical company, but we're also a big plastics producer, and I'm going to focus my comments today on plastics because I think it's in everybody's minds. Of the 350 million tons of plastics produced and used worldwide every year, around 50 million tons of that are locally produced here in the European Union, used in the European Union, and most of that is locally produced. And we in the Dow Chemical Company, we have 3 major production sites in Germany, Spain, and the Netherlands, and we'd like to keep them. We'd like to keep producing this high quality plastic for the applications where it's used. Now, our product basically is carbon, so that's a very interesting aspect here. We take fossil fuel-based hydrocarbons and we produce plastic, and one of the byproducts is a kind of energy that we also use in the plastic production. So it's very, very efficient. We do it very well, and society uses plastics in many, many ways, as you know. For years, we've been working on efficiencies, how to use less energy, how to make more product with less, and also in the design phase, how to make products with our partners, obviously, because we don't make the final products, but we collaborate with partners, how to make them lighter, how to make them more durable. If any of you sort of around my age remember plastic bottles, a few years ago, they were pretty rigid, solid things. They were quite thick. Now, when you finish your bottle of water and you carefully crush it before placing it into the recycle bin, as I know you all do, it's like a kind of a paper almost. And that's come through this technology of efficiencies and lightweighting, etc. But we have not closed the loop. We have not closed the loop, and as the plastics production has increased over the years, waste management systems have not kept pace with that, and we didn't pay enough attention to that. It's unacceptable that plastic waste ends up in the environment. And reading the material economics report, which I really encourage you all to do, it's very good to see that the twin aims of closing the loop on circularity, which we are fully committed to keep plastics out of the environment. If we do it in the right way, we can also get to zero carbon, or pretty close to zero carbon, which of course is the topic today. So those two things are completely linked. And as plastics use is growing, obviously there are these efficiency in productions, but in the use phase, we often help with emissions, right? Insulation, lightweighting of cars, all that sort of thing. But the end of life is not only what needs management from what all of us see as citizens from the unacceptable plastic waste in the environment, but also that's where all the carbon is. And it's very interesting in the report that they sort of have this idea which they immediately say would not be socially acceptable, and I agree. Well, we could just store the plastic somewhere, right, as a carbon sink. Now, that is not one of the solutions we're looking at. So what solutions are we looking at? It's in the report. I'm just, just being the honest reporter here. Different plastics recycling technologies exist. And a lot of us are very familiar with mechanical recycling, where things are segregated, washed, clean, chopped up. And I visited one recently, actually here in close to about 100 kilometers away with Fortum company, doing some fantastic things there at the Eco Village. Mechanically recycled plastic has limited applications because it doesn't have the quality and the technical capabilities to go in things like food packaging, medical products packaging, things which need a very high level of quality and cleanliness, obviously. So we are looking at very closely, actively working on pilots in the chemical or feedstock recycling part, which is going to be very important for our futures. And actually what that means is you're taking the end material back basically to its constituent parts. There's different processes, so I'm glossing over all of that. But what you get is a new raw material. And that new raw material can then be used to make pretty much anything. So I think we're going to have a chance for some Q&A, I think, afterwards. I've got a couple more points, but seeing as I'm at the end of my time, I'd just like to end there that zero carbon is possible through a combination of recycling, end-of-life management, and some other technologies which we'll talk about. Thank you.
Thank you very much, Lorraine. It's exciting to always to hear that everyone says that zero carbon is possible. That's something that you didn't hear 5 years ago, let alone 10 years ago. So we've speed forwarded a few years in the discussion, but we will need to pick up the pace also going on in the future. The next speaker we have is coming from Norway, and he represents the Norsk Hydro, or known as Hydro as well. He's the executive vice president at Hydro, head of Extruded Solutions, which is Hydro's largest business area, offering solutions in aluminium to a wide range of industries. So please welcome with me Mr. Egil Hogna.
Thank you. Good afternoon, everyone. So I work for one of the world's largest aluminium companies, and what distinguishes us is that we work in the entire value chain, all the way from the bauxite, which is mined, through the alumina refining, the aluminium smelting, the production of intermediate products, and then finally parts for cars or even windows. We work in both value chains, both in the production of the primary metal and in the recycling. And one of the great things about aluminium is that it's very easy to recycle if you have fairly clean scrap. But making sure you have clean scrap, that is a very key ingredient. On this slide, which is my only one, I have put up the process which I think we need to go through in order to have a successful circular economy. And it all starts by educating ourselves and society, which is essentially what we are doing today. And when I say ourselves, it includes, of course, our own industry, because it all starts with what the industry itself is doing. The first element is understanding your material from a life cycle point of view, because materials are different and they have different benefits for different applications. Aluminium, for example, is quite lightweight. So when you compare it with other materials, you need to take that into account, that, for example, it weighs 1/3 of the steel. It is better when it comes to maintenance compared to a window made out of wood or plastic. It requires much less maintenance and it lasts for a longer period of time. So when we calculate our carbon footprint as a company, taking into account the benefits of the life cycle of the material, it is quite an attractive material for applications in transportation and where, for example, heat conductivity is is important. We then need to try to produce both the primary metal and the recycled metal as efficiently as possible with the lowest possible emissions. And I'll get back to what we are doing relating to that. But if we do not work with the rest of the industry, with the rest of the value chain, in terms of getting a design for recycling, it becomes a very inefficient process. For example, today we see some cars which are produced in a way which is facilitating recycling, while other cars are not. Cars which contain lots of different materials put together in a way which makes them difficult to disassemble are actually very costly to recycle. And we try to work with designers to make sure that they design products that are easy to recycle. For example, we have a furniture series produced together with IKEA, where you can take the entire frame and just put it into one of our remelters, reducing the emissions and the costs of recycling tremendously. Then we have the last subpoint here, incentivize recycling. One of the challenges we see today is that it's very difficult for consumers and other customers to distinguish between aluminium based on a low emission production and aluminium based on a high emission production. Today, our production is mainly based on hydropower. So, on average, my company has a carbon footprint of the aluminium, which is about 1/3 of Chinese coal-fired production of aluminium. However, if we look at the aluminium we have, which is produced exclusively on hydropower, the footprint is only 20% of, again, the Chinese aluminium. And if we look at the one which is based on minimum 75% produced post-consumer scrap, it's only 10%. But today, this is very difficult for consumers to see. So what we need to do is to invest in greener production, which we partly have done over quite a long period, but which we continue to do, both in greener production of primary metal and greener production of recycled metal. But then we need to also differentiate and market the greener products. And it is when we do that that we are able to get into this virtuous cycle where we will also see the demand for environmentally friendly products increase. And what I would like to end with is to show you our 2 new brands which are launched this year. One brand is Reduxa, which is the brand we have for the most environmentally friendly primary or virgin metal. And the other one is called Circal 75R. And this brand is used mainly in facades and windows. And with that brand, with that material, you can build a building like Finlandia Hall with the aluminium facade based on minimum 75% post-consumer scrap. So that means that end-of-life aluminium, so old cans and wheels and also windows that have been recycled, can then get a new life, becoming a brand new facade with a minimal CO2 footprint. This is available today. We will brand it to make sure that the information gets out to consumers and customers. But we also then depend on authorities like the European Commission to help us in making incentives so that it actually pays off to do this kind of production, which is, as was indicated in the first analysis, slightly more expensive than the normal production, because there will be a slightly higher price, but we hope that customers are willing to pay a little bit extra and that authorities are willing to make sure that there are incentives, either in the form of taxes on less environmentally products, less environmentally produced materials, or positive incentives for those that have a low environmental footprint. And by doing that, we together as industry, consumers, authorities, and other customers can create a successful circular economy. Thank you.
Thank you very much, Egil. And I'm inviting you to take a chair, and then I'm inviting your colleagues also to join you in a brief panel discussion for which we have around 25 minutes time. It was great to hear that basically the conclusions also from the aluminium standpoint are that basically just need to educate ourselves, but also the society, and then differentiate and market the green products. That's of course something to start with. But now that we have the panel setting seated, I'd like you to continue on reflecting from the perspectives of your companies. Martin, what do you think for SSAB, what are the key barriers holding back on the transition? You presented an inspiring technology case, but why don't we see that already in practice in 5 years or already today?
Yes, of course. This scaling up of this technology, we will need to do a very serious development work, because this needs to be tested before we can invest huge monies. But we will do whatever we can make it quicker. The most important aspect then, after we have succeeded with this pilot plant test, is to create conditions for the transformation of the steel industry. The steel industry is very capital intensive, has been for a very long time, so we need to have a plan to transform the current production assets to the future, more sustainable one. And to do that, we need to have good access to fossil-free electricity, which will need society support, not only in terms of production capacity, but also in transmission networks, and also speed up the process for getting permissions to do this transformation. So that, I hope, will be possible very soon when we have shown that the technology works.
So basically, one of the key barriers to overcome is the technology itself, but then the other conditions around it, meaning the access to emission-free electricity, and then of course the whole market environment around it to push it to the market.
Yes.
What about Lorraine? How does it seem from chemicals and plastics point of view? Zero carbon is possible. You said it.
I said it.
But what's holding you back?
So in the report, when you see it, you'll see zero carbon is possible because basically there'll be 2 feedstocks in the future. And the feedstocks will be recirculated plastic, and then the topping up that's necessary for the new carbon coming in, because you can't recirculate completely at 100%, will be from biomass. So it's possible. Now let's talk about the current situation that we have with actually getting back all that plastic. And I said this morning in another session that we want our plastic back. We don't want it to end up in the environment. It's completely unacceptable. Now, when we, as consumers and as end users of plastic throughout the various applications it has, you all know how dispersed that product is, getting it back. And I like the fact that this term economic has started to creep in front of the word recycling. Economic recycling. Now, maybe some people don't like that word, but we're here, as I said, in business to stay here in this region, making products for this region. So what we've got is a really efficient, highly McKinsey'd industry, as I'm sure we have here in steel and aluminium as well, where we're just fantastic at taking that raw material that we currently use today and making the products that are then used in society. And so that's one reason, is the fact that the whole integrated system of waste management and infrastructure, as well as scaling up of the technologies to do different types of recycling to make that product usable in all of the end uses that I mentioned before, needs to happen as well. For the other piece on the biomass, I'll just mention that briefly. I'm definitely not an expert on that. But as I read in the report, there is a question mark about how that biomass would be provided without interfering with other systems that clearly need the land and the water and everything else that's involved with biomass. So I think it is possible. I don't know if anyone's putting a date on that other than the dates that we have in recycling legislation, etc. at the moment.
Thank you. Just to touch on that, 2025 is the date or the year that Dow has placed as a strategic priority or as a goal. What does it mean in practice? What are the success factors that you are evaluated against?
So we're looking, and I'll talk really for the European Union. I think it's better as we're sat here. We're looking obviously at the circular economy package that came out and all of the recycling targets that are there for plastics, as well as other materials, of course, because this is largely, and again, I don't want to stray too much from the carbon side, but I think all of waste is unacceptable as we look forward to 9 billion people on the planet. We can't afford to waste a single molecule. And one of the areas where we're really focused is on food packaging, making sure that packaging contains the recycled content, is recyclable or compostable by the dates required. In the meantime, we still need to protect food. Someone has said and calculated that if food waste was a country, it would be the third largest carbon emitter, greenhouse gas emitter in the world if food waste was a country. It's that bad of a problem. So obviously we want to move forward, and we will move forward with our targets, but we can't also drop the benefits at the same time.
Thank you. And I love the way how you frame it, that waste basically is unacceptable.
Yeah.
For me, waste is something that's a measure of inefficiency, and circular economy as a concept, in very brief, is all about eliminating the waste, so eliminating the unacceptable inefficiencies. And that's of course the way we want to drive it as well. But Eagle, you already mentioned a few key barriers, and something that we discussed beforehand is the whole thing of defining green materials. We talk a lot about recycled content, and that's what we've done also in this session. But how do you approach the definition of green materials from Hydro's perspective, and how do you see that develop in the future?
Well, we try pushing the limits all the time. Essentially, there are two categories, as I said. It's the greener products based on the primary or virgin metal, and then there are the greener ones based on recycling. But by switching different feedstocks to fossil-free fuels, we can make both of them greener all the time. And right now, let's say what are the limits for green are what I just mentioned, but we hope that in a 10 years perspective, based on continued technological development and moving absolutely everything we have in terms of feedstock energy to fossil-free, we will be able to get to much lower levels than what we are at today. So it's a little bit like the elephant. The only way to eat it is piece by piece, and we're working on it. But through the support of conscious consumers and authorities who incentivize greener production, we will be able to accelerate the process.
What about, it's good that you mentioned the consumers, who at the end are kind of in the center, in the core, but you three are representing companies that mainly don't market directly to consumers. But how do you see this with your clients and your customers? How important resource efficiency is for them as a criterion? Eagle, go ahead.
Yeah, one key problem here are the intermediaries. So the wholesalers, if you like, which typically are in between us and the consumers, because we see many of them which are mostly interested in getting the lowest possible price so that they can have many suppliers to choose from. Having a differentiated solution based on particularly environmentally friendly products is not always what they are demanding. However, the consumers are demanding this, and this is why we see a need to actually go and market the availability of environmentally friendly materials all the way to consumers, even if there are companies and customers between us and the final consumers.
What about SSAB?
Yes, I think the situation for steel is very similar. we see now the increased consciousness of consumers putting pressure on car producers, especially now when the electrification of cars starts to take away the emission from the end pipe. The life cycle perspective of car production, the CO2 footprint, becomes more important. So we already notice that from the automakers, interest in our project is increasing. And this is really giving us a hope, because probably similar to also aluminum, steel industry is a raw material that is having a very pressed margin business. We need to get support from the consumer side in order to take care of the increased cost that Per has showed. That switching to this more sustainable way of producing will, at least initially, create a higher production cost. And the industry itself can't take that at the moment, since we don't have those margins. But hopefully that this will change in the future.
So I want to take a slightly different tack if I can, and I'm a great consumer. I do lots of shopping, all right? And honestly, I think that the pressure for us is really coming from the brand owners rather than consumers. And I think the brand owners, quite rightly so, you know, they want this fixed. They obviously want to meet all the targets that are being set in place. And we regularly hold sessions we have something like a design studio where it's called Pack Studios, where we have customers and brand owners, because actually our customers are not the brand owners. We sell plastic pellets to converters. There's a very complicated supply chain, right? But we do engage, and that's one thing that circular economy has been very positive about. We're engaging now with actors that we've never engaged with before, and that's so key. We cannot solve circular economy as one company, and we have to talk to everybody, and talk probably in a different way than we've ever talked. So we work with the people in our value chains, let's stay on food packaging, to improve the design, use less material, but to also incorporate, for example, recycled content into that material. But when I go shopping and when I talk to my friends and I talk about consumers in general, and I know there's various studies that have been done and you probably can find different answers, I'm not, people don't want plastic in the environment. So that's really where I'm focused right now. That's why we started the Association to End Plastics Waste. But I don't hear people say to me, oh, I want to buy that because it's zero carbon as much. Maybe I'm wrong, but I think, and also what I hear a lot in places like this is, let's all let the consumer make educated choices. And I do want to buy your aluminium garden chairs, right? I promise I'll buy those, the lower carbon. So I want labeling that I can trust. So there is an element of that. But if I'm in a supermarket and I'm looking at, you know, two packets of cheese, I'm not going to really worry at that one moment which has the lowest carbon footprint, I'm afraid. So it's a mix.
Yeah. And the same thing is with me. When I'm shopping, when I'm looking at 2 packs of cheese, I know I want to choose the one that has a lesser CO2 footprint. But even though I've been in this scene for a few years, it's impossible for me to identify whether it's the cheddar cheese or the Gouda cheese that has a lesser CO2 footprint. So that's, of course, one key thing. I've already started skipping my cheese, but that's the next step. But when we look at how these things are going forward, you can see that there's the clear policy push. Then the technologies are developing, and then there's the end consumer, and then there's the whole value chain approach. What do you expect from your industries? What are the key next steps that will actually concretely materialize in terms of moving towards circular economy? Starting from Martin, how do you see that in steel industry?
For the steel industry, of course, there are a lot of initiatives around, especially in Europe. I think the European Union has really interesting programs. As Mr. Kosigo talked about, the steel industry in Europe has presented a master plan. So there are a palette of different technology developments that need to proceed. We are getting increased support from the Commission. I hope that this will continue. But then in the end, all of these initiatives mostly in the end end up to excess of fossil-free electricity. So that will be one of the key success factors for the, at least, steel industry to go to a more sustainable production setup. If we want still to keep the industry and manufacturing business in Europe, we will need to work together. So the value chain from energy, iron ore and steel, as we are presenting in the hybrid project, I think this creates a good example if we can succeed.
Very good. What about Egil?
Well, increasing recycling capacity in parallel with the demand for recycled materials developing, I think is where we can contribute and where we need to invest going forward. And for those of us working in the downstream part of industry like myself, it's a lot about this educating and making sure that both the brand owners and the consumers are aware that there is a choice. You have an opportunity to decide on having materials with either a large or a small carbon footprint.
Very good.
Yeah.
What about Lorraine?
Well, we're in a really interesting place because at one point we clearly understand what sort of technologies would need to be developed. We are working on those technologies. We're working in the value chain. We're working on the whole issue of waste systems management through our various organizations that we've set up. And it's been mentioned before about the cross-sectorial stuff that's happening. So, working, in fact, between chemistry and steel, we're taking some of the carbon emissions from the steel industry, for example, to produce products. At the moment, we have a project called Carbon to Value that we're working on. However, at the same time, we have to maintain just say that the materials that we have, it's like in the report it said, and it was mentioned also in the presentation this morning, some of these decisions for major companies with major assets, if it's badly implemented, can turn into a bet the company decision. And I can't go to my business president and ask them to bet the company. So what we're trying to do is work with the legislators, with industry partners, down the value chain to sort of start here where we are, and build this up. It's a classic, right? You start, this is not big enough, this is too big, that's too small, and you're trying to do this, right? So you're going to have this just transition with all of the other benefits that we need to talk about, the social side as well, which we haven't mentioned very much about. And I believe that the materials that are produced and are used in all of these applications, constructions, packaging, medical, etc., continue to be needed. So we've got the demand being very strong, but also we need to meet, obviously, the carbon and waste challenges that we have.
That's indeed an excellent point. I know that we have kind of an interesting autumn coming up in the policy side when the new European Parliament is stepping in and they're starting to work on their working plan. We have a few minutes time, and I know you're not lobbyists by heart, but now you can play that role. If you would have a chance to advise some of the people familiar with the European Commission in the room, probably in the front row as well, what would you say to them in terms of what are the key requirements and hopes from your industry side? Let's start with Martin as well.
Yes, of course, as I mentioned earlier, the support that we need is very important for us to make these very important decisions in the coming decades. Just as Per mentioned, the industry is facing only one cycle of investment until we have to get there. So the earlier we can make the choice of direction, the more easy for us later on that we can reach our targets. So policy support, including support to risk-taking in our very challenging scale-up process, which is one of the key. The second aspect is to create a level competing field for us. because the steel as aluminium is a product that is treated globally, and we need to have a system that the product that we can make with the lower carbon footprint is valued in a way that is supporting us to make this business decision. I think that is one of the key issues for us as an industry.
Yeah, excellent. Thank you.
The table started going down as you were speaking.
Did you share notes?
No, we didn't share notes, but the table was decreasing. It was like it was metaphor for carbon, right? It was decreasing. It was just a metaphor.
It's good you spotted that. Yeah.
I mean, I can only. So I don't know who you wanted to go, and I'm not going to. I just agree with what was said there, and I think the collaborative, the getting around the table, the involving the different sectors, working together. We know what to do. It doesn't actually cost that much, as was said at the overall level, but there is no global government. There is not going to be a global government. And when you talk about it at the company level, it can be a really big hurdle to climb. So I think this continued way of working and really not trying to oversimplify it. And I don't think anyone does that on purpose, but I think sometimes I see some and I'm sure I do it too, right? All of us. We probably oversimplify the role of the other or the impact of the other, and I think we just need to keep talking much more and getting the right messages out. Sorry, but I agree with you from the steel side. Yeah.
Thanks.
Okay. I come from a country, Norway, where more than 50% of the cars sold so far this year are battery electric vehicles. More than 50%. How is that possible? Well, it's possible partly through conscious consumers, but mostly because of incentives. Because cars that are based on fossil fuels, gasoline, diesel cars, they are heavily taxed. So that when the consumer makes the choice, then from a financial consumer point of view, it's more or less the same. Electric cars are not more expensive than diesel and gasoline cars, and that makes the choice easy, and it really speeds up the development to a net zero carbon future. I think the solution is similar for materials like our own. If there would be a tax on the heavy carbon footprint version of the materials, it would clearly incentivize customers and consumers to make the right choice and buy the materials and the product based on materials with the lowest footprint. So I don't think that the solution is very complicated, maybe a little bit difficult and requires some courage to make those kind of decisions, but it is a solution that we know that works.
Excellent, very good. And that's also summing up the kind of key learnings from the session. As I see, we are 10 seconds down our time. So basically, what we saw in the beginning in the Paris presentation is that the challenge, of course, is massive. But the positive news is that we can achieve it. It can be done, and zero carbon can be reached. The question is that how do we devise a policy environment that leads companies to that direction? And then when we come to your ending remarks, it's all about setting the right direction, setting the targets, supporting risk-taking and scale up, and just to have the right incentives and the level playing field for different companies from different jurisdictions, and then collaboration in value chains. And I think those are pretty much the key learnings we can all share within this, because they are, first of all, they make sense, they're logic, and they would lead us towards a better future where the zero carbon in materials emissions is ahead. So I would like to thank our panelists and our other speakers and conclude the session here. Thank you.